Hello everybody, welcome into another lesson. So today we are going to solve equations in rational power form. The previous two lessons have been root equations, where essentially if you have a square root, a cube root, a fourth root, what have you, those have all been the same as the variable raised to the 1/2, the 1/3, 1/4, 1/5 power, what have you, meaning it was the fifth root or fourth root, third root, second root raised to the first power. Today we're going to have other roots raised to different powers. So x to the 5/2 equals 32. That's the same as the square root of x raised to the fifth power. So how are we going to solve this? Well, if x is raised to the 5/2, you have to then raise both sides to the 2/5, right? That would cancel out the exponent and get x by itself. So if you do that, you'll get x equals 32 to the 2/5. Now, what is 2/5 the same as? That's the same as the fifth root of 32 raised to the second power. So we can write that. X would equal the fifth root of 32 raised to the second power. Now, what is the fifth root of 32? Well, that's 2, so x would literally equal 2 to the second power, which would have to mean then that x equals 4. But just like with the previous two lessons, if you also have rational powers, you want to check for extraneous solutions. So put the 4 ends now to the original. So this is saying that 4 to the 5/2 equals 32. Well, is that true? This is the same as the square root of 4, all that raised to the fifth power would equal 32. What is a square root of 4? Well, that's 2. So you'd have 2 raised to the fifth power equal to 32, and 2 to the fifth power is 32. So 32 equals 32 actually holds up. So your solution is that x equals 4. In this case, you do get that x equals 4. I got about 8 more. Alright, we have x to the 1/3 minus 2/5 is equal to 0. So we have x to the 1/3 minus 2/5 equals 0. Well, I would definitely get that x to the 1/3 by itself. So this is going to look a lot like, let me find the right color, x to the 1/3 would equal 2/5. Now, of course, we want to get x by itself, right? So we need to raise both sides to the third power. So if we do that, you'll get x would equal, now 2/5 of the third power, that would be 8 125ths. We have x would equal 8 125ths. But we have to check and make sure that this works. So put in that x value into the original equation. So this would be 8 125ths, all that raised to the 1/3 power minus 2/5 set equal to 0. Well, 8 125ths to the 1/3 is in fact 2/5, so you would get 2/5 minus 2/5 equal to 0, which would then give you that 0 equals 0. So yes, this checks out. The solution would then be that x equals 8 125ths in the end. All right. X to the 2/3 plus 15 equals 24. So now we have x to the 2/3 plus 15 equals 24. Well, let's get that x to the 2/3 by itself. So if you do that, this will turn into x to the 2/3 equals 9. Well, we want to get x by itself, so that means if it's raised to the 2/3 power, we have to raise both sides to the 3/2. So if we do that, you'll get x equals 9 to the 3/2 power. Well, what is 9 to the 3/2? Isn't that the same as taking the square root of 9 and raising it to the 3rd power? Alright, so what is the square root of 9? That's 3, right? So this x would equal 3 to the 3rd power. Now, what is 3 to the 3rd power? That'd be 27. So according to this, x would equal 27, but we need to make sure this actually lines up. So we got to check and make sure this is not an extraneous solution. So put in that x value of 27 here. So 27 to the 2/3 plus 15 equal to 24, which is the same as the cube root of 27 raised to the 2nd power plus 15 equals 24. Now what is the cube root of 27? That's 3, so this would be saying 3 to the 2nd power plus 15 equals 24. 3 to the 2nd power is 9, so you get 9 plus 15 equals 24, which would give you 24 equals 24. So it actually checks out, which means that x equals 27 is the solution to this equation. So x would equal 27. I have about 6 more. All right. Negative 1/2 x to the 1/5 is equal to 10. All right, so negative 1/2 x is equal to 10. Well, let's get that x to the 1/5 by itself, so multiply both sides by -2. You'll end up literally getting then that x equals x to the 1/5 rather would equal -20. Now we have to raise both sides to the 5th power to get x by itself. So x is going to equal a god-awful number. This is not going to be fun, I can tell you that. Raising -20 to the 5th power. Negative 3,200,000. Alright, so according to this, x would equal negative 3,200,000. Well, we still have to check and make sure this lines up. So let's take this x value, put it into the original. So negative 1/2 times the quantity of negative 3,200,000 raised to the 1/5 power would equal 10. Well, this is the same as negative 3,200,000 raised to the 5th. It's a 5th root of that, right? Which we just found would be -20. So this would give you negative 1/2 of -20 would equal 10. Negative 1/2 of -20 is 10. 10 equals 10. So we have a true statement. This actually checks out. So x is the incredibly large negative number of the value negative 3,200,000. That's a big negative number, but that's exactly what the solution is. All right. 4x to the 3/4 equals 108. So we have 4x to the 3/4 equals 108. Well, I'm going to suggest we get the x to the 3/4 by itself, so divide both sides by 4. You would get that x to the 3/4 would equal 27. Now, if we have x to the 3/4, in order to get x by itself, we have to raise both sides to the 4/3 power. So if we do that, you'll get x equals 27 to the 4/3 power. Now, what is 27 to the 4/3? Isn't that the same as the cube root of 27 raised to the 4th power? Alright, so what is the cube root of 27? That's going to be 3, so this x would equal 3 to the 4th power, which means x would equal 81. But let's check this out and verify to make sure this actually holds up. So take 4 times 81 raised to the 3/4 power, set that equal to 108, which could simplify into, okay, the right side, 108 divided by 4 is 27. Now, 81 to the 3/4, isn't this the same as the 4th root of 81 raised to the 3rd power? What is the 4th root of 81? That's 3, so this would say 3 to the 3rd is equal to 27. Well, 3 to the 3rd is 27. You get 27 equals 27, so this actually holds up. So the value of x that you're looking for is what we got. X equals 81. Got 4 more. X minus 4 to the 3/2 equals -6. Well, I'm going to make our lives a lot easier here. X minus 4 to the 3/2 equals -6, right? Okay. Well, let's still, no, you know what? We better just take all this to the, we better just do everything here. So, let's go ahead then, raise both sides to the 2/3 power. So if you do that, you'll get x minus 4 equals -6 to the 2/3 power. Okay. So you still have x minus 4 is equal to, this is the same as the cube root of -6 raised to the 2nd power. Which would give you then that x would equal 4 plus the cube root of -6 raised to the 2nd power. Well, what do we know here about cube roots and negative numbers? You can extract a -1, right? A cube root of -1 is in fact -1. So x would equal 4 plus negative of the cube root of 6 raised to the 2nd power. So let's see if this actually holds up. Does this actually hold up? I don't think it's going to. All right, that would be a little over 3. So here's the thing. If you add all this together, x would approximately equal to 3.302, right? That's what this would equal. Now here's the thing. We got a couple things wrong here if you put this into the original. Notice the root index in the original is 2, right? Which means it's a square root. If you take 3.302 minus 4, you're actually going to get a negative number in the root. So it doesn't hold up because it's undefined in the real numbers for an even power root. And even if the number did work, it's still not going to work because you can't take a square root and get a negative number. So really, we have no solution. Really and truly, there's no solution to this one. Nothing holds up. So yes, we did all that work just to find that we got an extraneous solution, which means this actually doesn't work. And you will have that sometimes. Okay. Should only have 3 more. We have the quantity of 2x plus 5 raised to the 1/2 power equals 4. So we have 2x plus 5 raised to the 1/2 power equals 4. Well, this is raised to the 1/2 power. We have to raise both sides to the second power. So that would end up giving you 2x plus 5 is actually equal to 16. Which would then give you that 2x equals 11, which would give you x equals 11 halves. But let's test the theory, see if that 11 halves actually works. So put this in here into the original. What is 2 times 11 halves? Well, that'd literally just be 11, right? So you get 11 plus 5 to the 1/2 equal to 4. What's 11 plus 5? So this would be 16 to the 1/2 equal to 4. 16 to the 1/2 is the exact same as the square root of 16, which would give you 4. 4 equals 4. This checks out. So x value, the only value that works is x would equal 11 halves. Two more. 3 times the quantity of x plus 1 to the 4/3 power equals 48. Yep, I got it right. So 3 times the quantity of x plus 1 to the 4/3 power equals 48. Well, get that x plus 1 to the 4/3 power by itself, so divide both sides by 3. You'll get x plus 1 to the 4/3 equals 16. Now, if the left side's to the 4/3 power, that means we need to raise both sides to the 3/4 power to cancel out the exponent. So x plus 1 would equal 16 to the 3/4. Alright, so what is 16 to the 3/4? Well, x plus 1 would equal, we have 16 to the 3/4. That's the exact same as the 4th root of 16 raised to the 3rd power. So this would mean x plus 1 equals, what is the 4th root of 16? So that's 2 to the 3rd, which means x plus 1 would equal 8. So x would have to equal 7. But does that hold the line? And you can put it into your second step here, because you just divided both sides by 3. You simplified a little bit. So let's do our check here. So let's see, 7 plus 1 raised to the 4/3 equal to 16. So obviously then we have 8 to the 4/3 equal to 16, which is the exact same as the cube root of 8 raised to the 4th power equal to 16. What is the cube root of 8? That's 2. This is saying 2 to the 4th power equals 16, and 2 to the 4th power is 16. So you get 16 equals 16. So yes, this holds up. So the answer you're looking for is in fact that x equals 7. That would be the solution, is that x equals 7. I have one last one here, then we're done. All right. So we have negative of the quantity of x minus 5 to the 1/4 power plus 7/3 is equal to 2. So negative of the quantity of x minus 5 to the 1/4 power plus 7/3 equals 2. Well, let's get that negative x minus 5th to the 1/4 power by itself first. So this will be negative of x minus 5 to the 1/4 equals, all right, so 2 minus 7/3, that's negative 1/3. Now you can divide both sides by negative 1. You'll end up getting x minus 5 to the 1/4 power would equal positive 1/3. Now the left side's equal to the 1/4 power, so you got to raise both sides to the 4th power. So this would turn into x minus 5 equals 1/81. So this is going to be a lot of fun. This will truly be a lot of fun. Okay, so x is going to equal, what is 5 plus 1/81st? Yeah, this is going to be a doozy. So that would be equal to 406/81. And I don't know that it simplifies. Not looking very good for it. Nope. It doesn't simplify any further, sadly. So now we have the final task of determining, does this actually line up? So let's go ahead and start putting this in here. So negative of 406/81 minus 5 to the 1/4 plus 7/3 equal to 2. All right, so we have the negative of, let's see, so this would end up being 1/81 to the 1/4 plus 7/3 equals 2. Well, 1/4 power is the same as the 4th root. What is the 4th root of negative, what is the 4th root of 1/81? That'd be 1/3. So this would be negative 1/3 plus 7/3 equal to 2. Negative 1/3 plus 7/3 is 6/3, which is 2. So you get 2 equals 2. That actually holds up then. So your solution is the god-awful 406/81. That would be your solution. That's it for this lesson. That's it for this unit, actually. The very next lesson, we're going to start the unit on exponential and logarithmic functions and their graphs, which is going to apply everything we've learned so far. So you really got to start thinking now in rational exponent form when it comes to these logarithmic equations. Be comfortable with the fact that the 1/2 power is the same as the square root, or the 1/3 power is the third root, so on, because those come into play big time in the exponential and logarithmic functions unit. In the very next lesson, we'll just introduce exponential functions. So I hope everyone has a great day. Take care.